My name is Schlomo, and I'm here to tell you a story that hopefully will be really useful to you, because I want to show you how you can establish secrets management for cloud and offline. Who here has secrets management and is really happy with that? Okay. Who here is only in the cloud? Okay. Who here is only outside of the cloud? Okay. Who here has secrets on their laptop without encryption? Okay. You have something to take home today. So this is a story I actually developed at my previous job, and I will disclose everything here, including how we do disaster recovery for secrets management. There's nothing you need to pay for that, it's all open source. So let's see what's actually the problem. And I think here's a problem with the wireless reception of this dongle. So, full story, DevOps. Who's not believing in DevOps? Hands up. I don't believe in DevOps. But I'll tell you why. Secrets, obviously, why? Functional, non-functional requirements. If you ever write a decision memo, please include functional and non-functional requirements. And this story here is sort of like a decision memo for secrets. And of course, I introduce a solution called SOPS, and we will see how we solve some problems with that. So, DevOps. I did a lot of DevOps talks, and I need to tell you, DevOps is not a product. It's not a thing that you can buy, and it please shouldn't be your team's title or your personal title. So if you do DevOps right, you land in happy DevOps camper land. And there's one thing you need to remember about DevOps, and that's the only thing you need to keep in mind. DevOps means people on one side, technology on the other side. The whole point of DevOps is putting all the people on the same side, playing together in the same team, sort of against the tech. The absence of DevOps means people are playing against each other, and the tech is just a representation of organizational discrepancies, fights, power plays, whatever. So put the people together, let them be together, let them be responsible together for whatever they do, for the delivery, for the operation, for the availability, and that's DevOps. Everything else is implementation. To be a bit more specific, DevOps is the result of doing the right thing. I invented 5 KPIs that will help you to measure your DevOps adoption, but it actually measures how much you do the right thing. Look at this website. This contains all my DevOps resources, talks, articles, blogs, whatever. Feel free to use it. It's open source. And please use DevOps to convince your managers to do the right thing. And then you can come and tell them when it's done. So, secrets. What is the problem that we solve with secrets? Very basic question, right? So, secrets come in play when we have people, systems, whatever, making a request to some services. And to secure the request, we send a secret along. If it was the right secret, you get a response. That's secrets, right? In a nutshell. So, why are secrets so important? Well, if you ask me, secrets are a legacy technology. Have been invented probably 10,000 years ago with people asking for a passphrase before being allowed into a little village, like, passphrase of the day. And since then, secrets management has been a problem. And it's still a problem because everybody thinks username and password is good enough. Well, truth is, it's not. And I wrote a series of blog articles. I gave some talks about lifting the curse of static credentials, going into a world where you don't have static credentials, where you use other means of identification instead of authentication. Because authentication is only a technical part, identification is what you actually want. The answer to the question, is that the person who should come in? Is that the service that should be allowed to come here? This talk today is not about secrets management. Look on my blogs, you will find infos. Today, we talk about functional requirements for secrets management. So why do we need that? Well, the world is as it is. We have secrets, so let's deal with them. Can't get rid of all secrets today. I would love to get rid of all secrets, but it's a really long journey. So try to take it step by step. Functional requirements, requirements that cover, describe what we expect from the secrets management themselves. So obviously, we like to use it, has to be easy, yeah, no brainer. Same for Git. We have all kind of secrets or formats needs to be supported. Automation friendly, obviously a functional requirement. Cloud and offline, I do believe in the data center. I do believe that the cloud can make poof and it's gone. So better safe than sorry and all that. Now, if you ever did any sort of security audit, least privilege access is a must. And very important also, it has to be flexible. Like we talk about encrypting secrets. So the question where to decrypt has to be flexible. Oops. You see? I can decrypt where I need to. I don't want to be limited in my abilities. So let's look at non-functional requirements. There's a lot of them. And typically non-functional requirements are things that your company cares about, like strong identity verification. I want to make sure that my developers read the secret and not somebody who looks like a developer but isn't, aka stolen laptop. Stolen laptop is a problem. Things get lost, especially on conferences. I've seen tech conferences where, you know, there are like 100 Macs in the audience, all open. Imagine you grab an open Mac, run away, and just use it. Nice, right? Easy, really easy. So you need to be able to deal with that. There's more requirements. I won't list them off, like offboarding. Yeah, sometimes you have a person and you need them to be gone now. Not tomorrow, not in half an hour, now. Because maybe they're doing something that you don't want. Let's skip through a few. Exposure of secrets reduction, tampering, change management for secrets. If you don't have change management for secrets, it means you're doing manual operations, running a risk of the wrong secret arriving in the wrong place at the wrong time, and not knowing what is actually in production. So change management needs to cover secrets. The part I really love is retain access to secrets at all times. The secrets are secrets because they are really valuable. If you lose the secrets, you typically get locked out of your own stuff. And getting back in might be somewhere between really difficult, time-consuming, or impossible. Imagine you lose the secret for your master backup, and then your server crashes. No server, no backup, tough love. So, yeah, your company will provide more upon request. Ask your CISO, ask your governance officer, and so on. They're happy to help you. So, what could possibly go wrong, right? And this picture is famous, so I'm using it with my own twist. Well, all my data is in the cloud, right? Nothing can go wrong. We all trust the cloud. The cloud is great. Well, reality is the cloud did burn not so long ago. And, well, where's the cloud data? These customers of OHV actually lost data for real. And those customers who didn't have their own off-cloud backup were busted. So don't be that. Other problems, doesn't go poof, but the vendor shows you something like this. Well, nice that we have your data, but we don't give it to you anymore for whatever stupid excuse. For you, the effect is the same. Physical proof or legal proof have the same effect. You are out of business. So I believe you need to own your data, and own means possess, in the pocket. It is here. Nobody can tell me what to do with it. That's my data. So, little side note on users are responsible. If you work in the cloud, you are responsible for all the hard stuff. Vendors only guarantee their operations. That's it. All the problems are your problems. And the vendor is always the winner. That's cloud. That's SaaS, actually. So wherever you use SaaS, think about that. So there is more you can read. I wrote a blog article. Main thing is data ownership doesn't equal data possession. Maybe take that home and think about it. I'm happy to talk with you about it. It's a big problem. And most SaaS users are not aware of it, which again makes me sad. Let's get to secrets operations. And if you use a SaaS provider for secrets operations, please think again. For the reasons I just mentioned. So SOPS is an open source tool, and it's actually an editor. So SOPS, as a tool, puts the human in the driver's seat, and it's a tool for humans to manage secrets. That's why it's an editor. And if you use an IDE, there are all plugins for all the IDEs to make it really easy to use SOPS. The key secret of SOPS is it has methods for encrypting and decrypting a secrets file. And depending on offline or cloud use cases, you can use different key providers for that. And to make it easier, you can mix and match as you like. And depending on the key provider, you can also give encrypt and decrypt permissions separately. And that's the magic of using SOPS for secrets management. All the way how SOPS turns into a tool for management lies in these encryption permissions. In the nutshell, I'll walk you through the details. Good news, it's a CNCF project, so the future of SOPS is now secure. There was a time where it wasn't, but now I think SOPS is really a tool that we can really well rely on, and it has a large community of users and also contributors. If you haven't heard about H keys, you should take a look. H keys are very simple keys, simpler than PGP, and they don't require any crypto infrastructure. You can even use SSH keys as H keys if it needs to be. So I will also be using H keys here. Let's look at the architecture. You have a SOPS encrypted file. It's just a file. Text file, by the way. Inside, you have encrypted values. And surrounding that, you have a so-called message authentication code. It's a hash that prevents tampering. All that is encrypted with a data key, which is symmetric cryptography. And this data key is in turn encrypted with an external key that serves, I call it trust anchor. And the fun part is you can have multiple of those with different privileges. So I'm using this term SOPS trust anchors because for me that's what's happening. The trust for encrypting and decrypting is delegated to access of or onto these cryptography methods outside of the SOPS file. But the data is just in the SOPS file. It doesn't have any dependency to the outside world beyond the access keys. Obviously, that's where offline and cloud comes into play. Some of these work offline and some of these depend on the cloud. HashiCorp is for me another cloud service, even if you run it yourself. With offline, I mean really you just need a file and a laptop and no internet and no nothing and you can work. That's for me offline. Like hardcore offline, like DOS, MS-DOS type offline. For those of you who are a bit older. So if you take a file like this, and this is the default example file, if you just do sops filename.yaml, you get that. So it's a human-friendly tool. It gives you an example when you open it. And that's how the same thing looks encrypted. And let's look at the details. So here, the keys in this case of a key value store, are plain text. So you can actually see what is there. And please don't put secrets into keys. We have values for that. And there are the values. This is the trust anchor ID. So the idea is that here could be a list of trust anchors, like you see age, and there could be more, like you see up there actually. KMS is Amazon, GCP, Azure, and so on. These are the different drivers, if you want, for your trust anchors. And here's the encrypted data key, and that's the fun part of it. All the materials necessary to decrypt the data is here, just it's encrypted with your trust anchor. And that's, in my opinion, the brilliance of the SOPS architecture. And here we have the tamper proofing. It's just there. If you ever try to mess with an encrypted SOPS file, you will see how it works. It just will refuse cooperation later on. So, a little bit ecosystem. It's open source. It's available for all platforms, obviously. It has plugins for everything. It is supported in Kubernetes and all the other kind of target destinations where you could imagine it. The tooling support is really, really great because, honestly, a lot of people are using it. And it also has a bunch of advanced security features like key rotation, 4-ICE principle in hardcore crypto file level, meaning you need two people who come with two different trust anchors to open a SOPS file. Nice, right? For free. You don't need the extra premium Enterprise Plus license. It's for free. You can use git diff to see where a secret changed. Really super useful. It does even support binary files. They will be wrapped. And there's support to create an audit trail or upload encrypted files. It's like for very controlled environments. You probably won't be using that unless you work in a bank and your users don't have any privileges. How do we use it? Well, really simple. The most important thing to remember is there's a .sops.yaml file, which is the local per directory configuration of SOPS. There, you ideally put something like this, creation rules. That tells SOPS which encryption key, which trust anchor to use for operating here, being this directory or a subdirectory of that. I'm using age as an example because that's the thing that you can do offline without any prerequisites. Typically, you would have their KMS or whatever. And please remember, in all cloud providers, KMS is a regional service, so please use 2 regions. So that when one region goes down, you can open the secrets to deploy to the other region. Otherwise, again, you're busted. Well, encrypting a file is as simple as that. That creates an encrypted file. Key equals value. SOPS supports like common file formats like JSON, YAML, property, and so on. Decrypt is also equally simple. You need to give SOPS access to the key, for example, via environment variables. In the case of the cloud providers, it of course will talk to the cloud provider to retrieve the key. And then you do stuff like this. SOPS-D just dumps it. exec-env and exec files are variants of how to start another process that can then make use of the secrets without dealing with the secrets themselves. By the way, don't use env. It's actually bad practice. Check on OWASP and other sources for don't put secrets in environment. Use exec file. That creates a temporary file, which you can then access from the daughter process. It's a read once file, actually a FIFO, unless you use Windows. And that's the way how you securely pass secrets into applications, for example, in a Docker container. Or you could go and put this SOPS exec file stuff into an init container that would then kind of inject a FIFO into the main container, or maybe a temporary file, or like millions of versions of how to do this. Although with Kubernetes, lots of people decrypt on kube control deploy or Helm chart deploy so that Kubernetes secrets then hold the secrets already unencrypted, trusting your Kubernetes platform actually. So how does it fit into your software delivery lifecycle? Well, here we answer all the requirements, by the way. Easy to use for developers within their native habitat. I'll need a bit more time, please don't worry. I know how to manage my time with the questions. I know how to manage my time. I'll need a bit more time for the talk and we'll manage it. Secrets are stored here and you do have a backup for your Git repository, I'm assuming. If not, then that's your homework. Decrypt early in CI/CD or late in production. And the nice thing, it's like a slider. For every application, you can decide where to decrypt. The tooling and the architecture stay the same. You can have your super secret high-value application where you decrypt very late and satisfy all the requirements. No problem, it doesn't hurt. It doesn't change your developer workflows, so to speak. Let's talk a bit more about the trust anchors. So we talked about you have engineering teams using a cloud KMS for encrypting and, of course, reading also. Yeah, if you can encrypt, you probably can also read. And then you have your CI/CD, but that can only decrypt. Why? Because you want to prevent CI/CD attacks from changing secrets in your Git repositories. So the asymmetric permissions enable you to do that for free without any extra effort. It's just setting the permissions on the KMS keys. And the same in production. You don't want production workloads to be able to manipulate secrets on the source side. You want to have a protection layer for that so that an attacker who comes into production can't inject their own secrets into your delivery chain. Easy to implement with the help of SOPs and managing trust anchors. And here's the fun part. You create an H key, encrypt everything as an additional trust anchor, put it in a safe storage, and that's your disaster recovery. As simple as that. Why? Well, as promised secrets management, right? That's it. That's the secrets management. It's just using the tool and thinking about kind of the surroundings. So, what happens in a disaster? We have again this picture, and all of that is gone, right? That's a disaster. The only thing you've left is your office with a locked cabinet and a piece of paper. And I'll be showing you this piece of paper in a moment. So what do? And question to you now, who prepared for this scenario? But what did you do?
We have a list that is manually handled by someone who is putting the piece of paper in the safe.
A list with the passwords.
A list with lots of secrets in it.
Very nice, very nice. Have fun typing it into the computer again. But very good that you are protected. What did you do?
Similar setup with paper, and it's stored in a little container in the post.
Very good. So here's an easier solution. So you still have that in case of the disaster, obviously. So what you go is you, of course, re-provision your cloud services, you restore your backups. But the problem is, now the SOPS file, there. You restore all the services, but all the new KMS keys don't fit your existing SOPS files because there's no backup for KMS keys, right? So what happens here is you open your safe box, you take out the piece of paper and use that to unlock your SOPS files. And this is called restore access to trust anchors. So you take your paper H key, load that onto your laptop, and then you do a single command. So first you update your SOPS YAML and put in the new trust anchors from the cloud. You run a single command, -y. -y means update the trust anchors according to the SOPS YAML. And that's it. That's your disaster recovery. Now the SOPS files match again your KMS keys. You commit it all to Git and you're good to go. End of story. That's the end of the story. That's how simple disaster recovery can be if you use the right setup. And your backup tool didn't change. Nothing else changed. You just put a trust anchor in a safe storage. That's how it looks in reality. SOPs will just change the trust anchors, remove the ones that are obsolete, add the new ones. That's it. Easy. Really easy. So how do you implement offline disaster recovery for your secrets management? You create a page, looks like that. I'll explain it a bit. This here goes into this little transparent window if you fold it in the German DIN lang, like triple folding. This here prevents people from holding it up against the light. And this here is the actual disaster recovery key in all its glory. And since we don't like typing, it's in the QR code for copy-paste. And that's why I'm using age as a cryptography here, because it's so simple and short that it fits in a QR code on a piece of paper. And there's even enough space for the documentation and usage hints and, like a bit of fluff around. And that's the paper that I put into safe storage at Forto, and they still have it, I hope. And obviously, after you use that paper, you also create a new disaster recovery key and put a new paper in your safe storage. It's a break glass trust anchor for your SOPS files. And that's how SOPS turns into secrets management with all bells and whistles that can really compete with commercial offerings and do even more for much less cost. Well, it's not the end of the story. You need a compliance checker. So at Forto, we have an internal tool called Repo Nanny, and I wrote a compliance checker for SOPs to run in that tool. It goes and checks that all the SOPs files have our disaster recovery trust anchor in it. Because if you don't check for that, developers will forget it, and then you're not covered. At the same time, you should check that hostile trust anchors are not part of your SOPs files. Let's say a developer puts his personal PGP key in to make it easier to decrypt your secrets after leaving the company from a stolen laptop, backup, whatever. So you see, actually, compliance for your secret management is important to cover all the non-functional requirements. I'm not aware of any open source tool that would actually deliver that type of compliance checking. I'm currently working with a client where we might develop such a tool and hopefully also publish it as open source. So reach out to me, then I can inform you once that happens. But this is, in my opinion, the thing that's still missing kind of in the industry, to really work with SOPs as an end-to-end covered solution. Compliance checking. So, we said cloud and offline secrets management. I added disaster recovery because I like that topic. And I believe managing operational secrets should be done with SOPs. I don't think there are many other tools out there that reach that level of feature completeness and developer productivity, ease of use, and of course, cost as that solution, SOPs. Please remember, no backup means no mercy. So go and get backups for everything. I hope you like this topic. I'm a consultant. I'm happy to help you. I typically specialize in management consulting, IT strategy, platform engineering, solving hard problems. But I also still like engineering. I'm still an engineer. So if there's anything that we can help you with, please reach out. Happy to support. I'm in Berlin. I travel all around Germany. English, German, no problem. Yeah, that's kind of it. That's my homepage. You'll find there blogs and articles and videos and whatnot. My email, just send me an email. I'm old-fashioned. I don't do all this social media stuff. Just talk to me, directly. Thank you very much. And we have time for questions. And don't be afraid to ask even technical questions. This is actually a tech talk. So. Who will use SOPs from this afternoon? Whom could I convince? Okay, that's not much. It's open source. You don't need to pay, you know. There's a free trial. Okay. Yeah, I mean, secrets management has to be integrated in your delivery pipelines, developer automation, configuration management, and so on. It's not a quick change to make really improvements here. Yeah. Okay, any questions? Anything I can do for you?
I have a question.
Please.
We have, for example, one pass provider which we store passwords in.
Yeah.
How to somehow integrate that?
You mean one password?
Yes. One.
Does one password provide an API?
Yes. And we consuming REST API, getting
Yeah.
secrets.
So one password as a secret storage for production secrets. I would ask, how do you handle change management? Meaning you have a secret in version 5, and you want to rotate that, so you create secret in version 6, and then roll out the production change to make use of secret in version 6. Did you automate that?
Not yet. We just started.
Exactly. So my answer would be, the moment you start to play change management for secrets, using kind of offset solutions like 1Password or HashiCorp Vault or whatever, start to be very painful, because you start to have multiple changes that you need to chain together in order to actually rotate the secret, which is why I personally put my secrets in the source code repositories, because that allows me to use the same change management process, meaning git push, pull request, release, whatever, also for secrets. And the secrets are just part of my code and are not so special anymore as they are when I put them somewhere else. So my answer would be, don't use 1Password for production secrets, because it creates more effort and pain than benefit, than you can actually get benefits from that. Also, I don't believe that 1Password will protect your secrets better than using something like SOPs and encrypted secret files. Protecting in terms of the wrong people reading your secrets and walking away with them.
But there is also a question where to store secrets for 1Password.
Yeah.
So that's always,
So,
as a programmer.
Yeah, exactly. For me, putting secrets in the source code is, by the way, the only way how to solve this chicken and egg problem of how do I get the password to access the secret store? And the reason is that you don't need a password to access the secret store. Your runtime is entitled to talk with the KMS service to unlock the secret store, which is already there. So it's a different approach. And with 1Password, if you could use workload federation, like workload identity federation, you would get in a similar direction. But you would still have a lot of the kind of change management related problems that only go away if you put the secrets together with your source code and treat them like one. And that's kind of the beauty of using SOPs and encrypted secret files in source code for secret management. Anybody here has companies where like compliance concerns would speak against using SOPs? Where the CISO would come and say, yeah, it's not secure, we can't control it, whatever kind of stuff like that. Because I believe I can defute all these arguments, but it's very difficult to talk to many compliance people from different companies. They somehow don't come to conferences and listen to tech talks.
So maybe other question.
Please.
GPG or that other tool?
H. Yeah.
Is the same security or just because I don't know H. I know more about PGP cryptographics, so I don't know what is H using. So
H is just plain like RSA, whatever cryptography.
Symmetric.
No, asymmetric.
Asymmetric.
Yes. H provides asymmetric cryptography similar to PGP or certificates. The nice thing is it's just the cryptography without all the surrounding stuff. You don't need a key server, for example. you've seen before the
because I understand
yeah.
that it has to be secure. Yeah?
Yeah.
Because it's for protecting your whole secrets.
Yeah. Look here. I showed you this, right? This string here is the public key. It goes about to here, that's it. That's the entire public key required for H. So H is super compact and easy to use. Whereas with PGP, here would be a PGP key identifier. And then in order to encrypt for that, you would have to have a key server that can receive it, retrieve it, or you would have to have the key already there. So it needs kind of, H is self-contained, while PGP is not self-contained. That's why I decided to use H when I discovered H when I did the research for Forto to solve this problem. I started my project with, we used GPG even though it sucks. And then I discovered that SOPS has another method that it supports, and I was like, wow, so much simpler. I was converted immediately to using only H for that. H is really small. It claims to have seen some security audits. I don't know. Can't tell you, honestly. Time will tell. I believe H is coming in terms of use, like more people are using it because SOPS supports it. And H can be also used, for example, to send somebody else an encrypted file based on the SSH keys that I know from that other user or that I pulled from GitHub. So if you ever need to pass a password via Slack to your colleague, you could use just H to wrap that.
Is it safe to publish your SOPS YAML?
You mean the encrypted file?
Yes, encrypted.
What do you mean publish? Like in a public GitHub?
Yes.
If you trust the cryptography, I would say yes.
So it should be safe.
I put it like this: better encrypted than not. If you go and watch my other talk, Lifting the Curse of Static Credentials, I will actually show there some big failures by big companies who publish their secrets via Git repositories in plain text. Big companies, like, industry-leading big companies. So secrets are a problem, and you need to encrypt them wherever you put them. Please.
There's a different tool called Git Secrets. I'm not sure if it's office Git thing, but this Git minus secret, and you
Yes.
need to install it additionally to Git.
Yeah. It's a plugin-based architecture.
Yeah, it sounds similar to this, but are there differences, or?
I'm not that familiar with Git Secrets. I've heard about it. I haven't used it myself, so I don't feel competent to answer you that direct comparison question. If you want, we can take a quick look later together. But in the end, I would always ask, what's the trust anchor in the cryptography? And then the management of these trust anchors is the actual question. If it's GPG, then I would say, please don't use it. Because GPG is hard to use, and you don't have an identification of the user at the time of using it. The cloud KMS keys actually give you that user identification. That's a big service of the cloud, that it's an online validation of the user performing the action. It's this user. He was authenticated in our Active Directory half an hour ago, and now he's doing it. This is a very strong identification of the actual person. Much stronger than a PGP key that just has a passphrase protecting it. By the way, don't use SSH keys, just as a reminder. Static credentials, big problem, easy to steal. And the passphrase is also easy to steal. Please.
Where to get the piece of paper? How to generate the piece of paper you showed earlier?
The piece of paper I created in Google Docs.
You did yourself. There's no tool for it.
I'm capable of using Google Docs and LibreOffice equally well. I'm sure you can find a way to program that in LaTeX. But yeah.
Not a problem.
I was too lazy to automate it because I needed one. Well, okay, fair challenge. You asked why I say automate, and I didn't automate it, so. Fair challenge. There are two reasons for automating. Who knows them? Come on, guys, ladies. Two reasons for automating.
Getting rid of repeated tasks.
Okay, that's quantity.
It's fun.
That's
For me.
emotional. But what are the two reasons you can sell to your manager? Exactly, quality. So one reason is quality, meaning avoiding mistakes, ensuring a predictable result. Even if you need it only once, that one time has to be so safe that it doesn't go wrong, that you automate it, try it 5 million times, and then you feel confident the one time it will also work. That's automating for quality. And the other is, of course, quantity, meaning I need to do it 5 million times, and the only way I manage it, kind of in my lifetime, is to automate it. So I would say this paper didn't really match the quality and the quantity criteria, because the quality requirement was my QR code reader decodes the SOPS, the H key. Everything else is actually fluff surrounding it. So I would claim I kind of managed to convince myself that I don't need to automate it. Okay, big thanks for being here. It's an honor to speak here. First time for me at this conference in Hamburg. I didn't know it exists. I will for sure be happy to come back. Great event, and I hope you all have a nice day, a great party, and see you tomorrow.